All right, welcome, Kirkwood School District Metric Notes. We're going to take a look at how we deal with this thing called the metric system. There are two goals for our video. The first part says students will be able to use metric units and numbers. So we want you as a student to know exactly how to label a number, write the number down correctly, and label it correctly. The second part, we want you to know which instrument to use to determine a measurement of matter. So you may be used to things like inches and yards and cups and pints, but we want you to get those out of your head. Deposit those customary units like feet and pick up some meters and use those meters inside your head. The meters are a part of an SI system, the International System of Measurement. In science, we use this metric system because no matter where you are in the world, you should be able to measure something consistently and communicate that to anyone, and everybody knows what a gram and a meter, no matter where you are in the world. In the first part of the goal, we want you to understand that when you have a unit of length, you should be able to correctly write it down and label it meters, millimeters, or centimeters. Okay, those are kind of the basic ones we'll be using in science class. Okay, if you have a unit of mass, you should be able to write down grams, kilograms, whatever it is that you measure, use the appropriate base unit and allow that unit to be, multiplied or add a prefix to it based on the degree of how large that item is. So for example, if you have a really small distance of length, you wouldn't use a meter stick. You would use your ruler and you would label it, most likely, since it's a small distance, centimeters. You would use the prefix centi to say that it's not a full meter, it's a part of a meter, and we're going to use this prefix to determine exactly what part of the meter it is. Okay? These prefixes are used for any of our base units within our SI unit of measurement. So for example, a kilo can be a prefix before the word gram for kilogram, saying that this is sort of a larger item and we have things that are a multiple of that gram. It's actually 1,000 of those grams in 1 kilogram. In the second part of the goal, not only are you able to use those units and labels correctly, but you'll know what instrument to use to get that number. Okay? So for example, you'll use a balance, either electronic or triple beam, to find the unit of mass. You'll use a ruler and a calculator to find regular volume. You'll use water displacement and graduated cylinder to find irregular volume. And then if you just have simply liquid volume, you'll use a graduated cylinder. And of course, you know length, a ruler and a meter stick. Okay? So to know what to do and how to do it for each of those different calculations is very important, and that's part of this video today. So when we look at mass, we use either grams or kilograms. A gram is about the size of a thumbtack. So when you place your thumbtack on your balance, you should be somewhere right around a gram. Okay? That gives you that concept. If you have 1,000 thumbtacks, then you have what's called a kilogram. Okay? It gives you a little framework or a benchmark. Okay? Now, when you measure the weight, though, that is something different than mass. Weight is a measurement of the force of gravity. Mass is the amount of matter in an object. So unlike weight, mass does not change with their location, even when the force of gravity on an object changes. So what's great about mass and why we use mass and why we use a balance and not a scale in science is mass is consistent no matter where you are in the world. Okay? When you are in different places, gravity may be different upon you, therefore causing the weight to change depending upon what location you're at. We use an electronic balance in science class, and we basically can put this apple right on there and we get a number. It says 73.5. But in 6th grade, we expect you to write down 73.5. We also expect you to label it as grams, the appropriate label. It's obviously not kilograms because it's not a really large object. We also expect you to be able to measure length. You use either a meter stick or a ruler to measure length. It's the distance from one point to another. So if we have this flower, for example, we set the ruler up against that flower. Very important thing to note. Look where the 0 line is for the ruler. Often when kids incorrectly measure something, they use the end of the ruler as a 0 mark. That is not always true. So please be careful when you are using your ruler that you can pay attention to where that zero line is. The zero line is set up there on the edge of the flower, and we're measuring the diameter flower from one point to another. We see that it goes just past 5, okay? So that means that it's past 5, but not quite to 6. So how we communicate that is we say 5.3 centimeters. Okay? Each one of those little lines is a millimeter or a part of a centimeter. You could also correctly write down this answer as 53 millimeters, since there are 10 millimeters for every 1 centimeter. Don't believe me? Pause the video, count the little lines. Next, we have 3 different kinds of volume. Volume is the amount of space an object takes up. Basically, how big is it? How much space does it take up? The first kind of volume is what you're typically used to is a liter. Like when you go to the store and you buy a bottle of soda, you typically buy it in liters. Okay? Well, if you only have a little bit of that soda, you have what's called a milliliter. Okay? But if you have an object that is sort of solid, okay, it could also be in cc's or cm3s, cubic centimeters. Okay? And that 3 is an exponent. Please pay attention to that. That exponent, of course, as we know and we learned in math class, multiplies that centimeter that number of times. So, 3 different kinds of volume. The first one's called liquid volume. Well, typically you use a graduated cylinder, you have a flat surface, and you bend down to the level of the water, and you read the bottom of the meniscus. That looks like this. Okay, the girl there is bending down to see the volume within the graduated cylinder. Now, if you read too high, as this diagram shows you, if you have your eyeball set too high, you're going to get a low reading. If you have your eyeball set too low, you're going to get a higher reading, and your answer is going to be incorrect. Okay, so your eye level needs to be the exact level at the bottom of the meniscus. Okay, so here's the sample problem. I've got 2 for you. Take a look at the picture there. Pause the video, see if you can get the answer. All right, the answer is 53 milliliters. So you see, here's 50 milliliters, here's 60 milliliters, there's 51, 52, 53 milliliters. Now, if you're really, really, really good, you'll notice that that little bottom water level is actually a little below 53. So if you said 52.9 milliliters, then you're blowing me away. That's awesome. You are really getting the concept of volume, and you are rocking it. That is above expectations. I love that. Okay? Take a look at this one. Try this one. Pause the video. Do it. All right, your answer. 10 milliliters is right here. 15 is right here. But these are a little different because this line right here is actually 0.5. So this is 10, 10.5, 11, 11.5. So we see that the bottom of the meniscus is at 11.5 milliliters. Now, what if you have the volume, but it's of an object, like a book or a cube? Well, then you use your ruler and your calculator to calculate length times width times height. This cube is pretty easy, and I use it as our example. It's 3 by 3 by 3. So 3 times 3 times 3 would give me 27. Now, we have to label that 27. We can't just leave that number without a unit. Okay? So it's 3 centimeters times centimeters times centimeters. That is centimeters cubed, or cubic centimeters. But what happens if this item is a sort of irregular shape, like a rock? Well, we can use what's called the water displacement method if it has an irregular shape. That means that you have a volume of water in a graduated cylinder, and you drop the item in the graduated cylinder. Now, when you drop the item in the graduated cylinder, the water level goes up. And what you do is you find the difference. So our example here has 200 before the rock dropped in. It was about 260 when the rock is in there. So the difference is 200, 260. The difference is 60. 60 what? Well, our graduated cylinder, as you can see, is labeled cm3, cubic centimeters. So we would say that the rock is 60 cubic centimeters. Now, density is a little bit more complicated. It involves a little bit of math. It's a mass of a material within a given volume. If you look at these 2 pictures, you'll note that one box has more circles in it than another box. That box is more dense. It has more material in a given amount of space. To get the density, you take the mass and divide it by the volume. Okay? When you do that, your units become grams divided by milliliters, or whatever your mass label is, kilograms maybe, or whatever your volume is, cubic centimeters, liters, whatever. Okay, but you keep it there. So here's a sample problem. Check this out. Okay, would an item sink or float? Well, take a look. We've got a block of wood. It's 100 grams divided by 150 cubic centimeters. Well, 100 divided by 150 equals 0.667. Grams divided by cubic centimeters is grams per cubic centimeter. So we get our answer 0.667 grams per cubic centimeter. Now, will that sink or float? Well, the density of water is always 1, no matter what it is. It's 1. Well, the block of wood is 0.67 grams per milliliter, grams per cubic centimeter. Since it's less, the answer is the block of wood would sink, and that's why we know that wood can sink. We had 2 goals in this video. I hope you enjoyed it, and I hope you learned a couple things. The first one, we want you to be able to use those units and label those numbers correctly. Second, we want you to know what instrument and how to use that instrument to find a measurement of matter. That measurement of matter could be length, mass, volume, liquid volume, regular volume, or irregular volume. Keep in mind, there's no cussing in science class. The following 4-letter words are forbidden. Let's keep it clean. Let's keep it metric. Have a good one. See you soon.